Hello everyone, welcome to Lab 1, Find Frequency Distribution with Natural Language Toolkit, also known as showed over here, NLTK. I'm Ricardo Lu. I'm a teaching assistant at Test Analytics class. Now let's get started. You might not be familiar with this title, but you are definitely familiar with word cloud. You put that in your report a lot. When you do a word frequency, you kind of go to Google and search word frequency, and it gives you a website or an app to do the word frequency. And when you type in or copy and paste all the words inside, it shows the word frequency, and you find out that there's a lot of words that you don't need. It doesn't make any sense when it's stand by itself, right? Like in the top, I imagine will be the, will be other a lot of terms we call it stop words. And you manually select what is meaningful for you and then put it into the word cloud. But today, what we are going to do is to learn how to use Python to manually tokenize, means use the word tokens to make a word frequency plot. And we import library to remove all the stop words. This will be lab 1. 2 weeks later, there will be lab 2 talking about other important issues. But today we are focused on 3 layers. First, string manipulation. We'll learn how to assign a string, how to strip, how to replace a string. Things like these, they are very important when you get into test mining and test analytics, right? Second, we are do tokenization. It sounds very professional, but what we are learn is we remove all the numbers. We put all the words lowercase so that it will be aggregate. All the same words will be aggregated easily. Third, stop words removal. It means that you will not see that there were there was there were all other words that are necessary in the word in a sentence, but itself stand over there doesn't mean anything. So that right afterwards, we will see a very, very meaningful tokens in the as a word frequency plot. First, let me talk about string manipulation. There are several things we can do when we start to do string manipulation. Is to look at the directory of string. So we find out that we can do several things. We capitalize them. We can use different format. We can index them, and there are several functions starting with is. You can guess it will give you some Boolean answers, right? So these are the things we can Google later, right? You can find out the list and you can find out what can we do about it later. Let's start to manipulate the string. So we assign a string. We assign a string object to assign a string to this object called S. You see there are double space, capitalized H, and others are lowercase. And just another space in the end. And what can we do about it? First, when we want to do a tokenization, we kind of want like just no space before and after, right? So the first thing we'll learn is to remove the space by using the strip function. The second important thing I want to mention is how can we do indexing? Indexing is very important. That it's very unique in Python because the first character is assigned an index at 0. That's why when you put S square bracket and there's 0 inside, you'll find out the first character is a capital H. And that's what we want. And you want to see the first is? Sure. It's the second character. So what do you remember is the first character is always a 0 in Python, which will be totally different in R, which you may learn later. You find out that sometimes you don't know when there's a long list, you don't know what it is, like what it is in the end of it. But there's another easy way to find out what's its last character in the string, right? You can see over here, we've immediately grab, without know how long the string is. Of course, we can know how long string is easily, but it's not applicable every time, right? So we have already successfully indexed the first one, the last one. How about second last one, L? The third last one, of course, it's another L. But just for example, so you will know that you can do forwards and backwards how to index a string. Also, you can find that over here, I put a column over here, which stands for that everything before and also including the fifth index. So you see over here that 1, 2, 3, 4, 5, right? Like you will see 5 over here. That's everything over here. You can, my bad. It's everything before 4. So it will be 0, 1, 2, 3. That's what it is. That's why it shows up like this. So when you do a comma over here, you will get everything before this index number. And what is also important is, as you see, that we'll use later, we lowercase everything to aggregate. No matter in the beginning of the sentence or in the middle of the sentence, we can aggregate every word together. Afterwards, we learn something very special because we are not used over here, but you will definitely use it when you process data, when you do a loop, when you want a Boolean statement over here. So you want to know is it alphabet or not? It will tell you if it's true or not. If it's a digit or not, it will tell you it's a digit or not. Sometimes there's there are this kind of booleans inside a lot of other algorithms that you might know, but you are not aware of it. They will pass it and remove all the digits. That's what we will learn later. And as you can see, we can check if the string start with HTTP. Of course it is, as we see. Then there's something very important over here, that we split a string into a list and we put the list joined together as a string. I will explain this slower than before. Over here we have a string called I love coding, and we wanted word by word I love coding in a list, right? We definitely want to aggregate it later, but we kind of want each word as it is in a list. So we use split. What it will do is split the string by its space. As we can hear the mark here is saying that the default delimiter is a space. So it will show you that a list that's separated by a space. And then we have a list, but what can we do after we did some manipulation, right? we want to sentence back together. There's an interesting thing, you can join them. I think this one is joking with me, talking about you can use the $sign, the double $sign, put in the I love coding because of blah, 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 right? But but definitely afterwards, you find out you don't want $sign, you join out this list, you put space in it. It is a space or double space, it's a space. So you replace, this is very commonly used. You replace them with a space. Sometimes you want to replace them with nothing. Of course you can do it. But what happened here? Replace, of course, because there's no $sign in the S right now. So I put double space into space. So right now I love coding. I still can read it for some reason. Now let's go back to what's in this natural language toolkit. First, of course, we install the toolkit. I don't know what happened over here. To find type command not found, but I already installed it. What we'll do is when you run it, it will show that it already installed. So I won't have any problem over here. I don't know what happened, but I don't have any problem over here. If your laptop already has the natural language toolkit, you won't have any problem at all. You don't have to run this box. Then you just import, and there's a frequency distribution over here. You need to import it specifically. And there are two methods right on over here talking about what we can do to import data. But for my own experience, I believe right now the website, most of the websites are encoded as WTF8. So you don't have to use method 1 unless there's a problem. So for me, I'm a strong fan of the method 2, which you can see that there's a little difference over here. There's RB, there's R plus. We can see the RB means it's read only, and it's for binary. It's only for binary kind of encoding. And over here, R plus means it can read and also you can edit. For me, I usually allow it to edit. Maybe you can use later. So highly recommend method 2. So let me run it. I won't have any problem because I already have NLTK. Before that, let's look at the dataset. And as we can see, the dataset has all the input over here. When you read it, it's very long, right? You can see it really, really long. And when you read it, you immediately know that it's talking about a canon and what it is. And you read it. Oh, there's a screen. And it has features. There's in-camera processing. You start to realize, oh, it's talking about, you see image processor. It's talking about camera. But it's like after you read a kind of 100 words over here, and then you realize it's talking about camera. But do you know that in the whole text, it's talking about camera? Here it's talking about modes of shipping. You kind of don't know after you read it all, right? So what we can do is use string manipulation. After we read the data, we know that it's a string. It's good. We can manipulate. We can use what we learned, right? And just one thing that you can figure out later, that you don't need to remember, you can figure out later. You find out in the raw data, yes, there's string, but there are slash ending in it. It means just going to another line. You will see it maybe over here when you read the data. So that's what happened. Let's go into tokenization. So in the tokenization, usually the first line of the code is what I do the debug. It will ask me to import a punctuation token. You don't have to remember that because after you do the second step, when I do it, when I do the debug, it asks me saying that NLTK is okay, but they don't have a specific library. So that's why I add this code over here. You don't have to remember it. It will tell you to do some addition after you run this code. So you just need to know that NLTK just for tokenize, and it's part of the NLTK tokens. You see that it take a kind of long time. We are still waiting on they process the load. They process the raw data into tokens. What it will do is give you a list of each words and remove all the punctuation marks. And after we get all the words, right? We kind of need to make it all lowercase so it will agree well, and also it will be weird when you see a word frequency with all the numbers on the top saying that it's 8, 9, 10, like you don't know what it means. So we kind of want words instead of numbers. That's what I will do over here. A lot of time. So this is a tutorial. It will run like this. You can see it's very for me, I usually use the for loop, but not as this kind of type. But it works, and it's very simple. I kind of want to learn how to do that, but usually I use the for loop and then just make it all lowercase. And I can understand this well, but I won't write like this specifically. There's a list comprehension, and then we append all the lower cases stuff. We make word 1 to remove everything that's already the same as others, right? We remove all the repeated ones. Then we do did we remove? No, we didn't remove. We just make it all lower cases. So sorry. So both of them are talking about how to make a lowercase. This is the way I highly recommend to write. But definitely this one is the one in my list to learn how to code like this. So after you have the words 1, over here the words 1 and words 2 are definitely the same over here. But we need words 2 because there's no numbers data over here. So when we do it, we use a frequency distribution function in the NLTK. We just import it, right? We import this specifically, and we can find a frequency, but the frequency will not be sorted. That's why we sort the frequency so that you can see it clearly what's on the top of it. I don't see any question if it's the words that don't make any sense. So like the first D, like the second I, and A2 is it. We don't know what it is until we have the camera over here. And we still don't need if, we still don't need this, right? First, let's make a plot and celebrate that we already did so far. That's what it is over here. We can see that we didn't sort it, but the plot sorted by itself and take the first 30. The first 30, the most frequent ones by the plot function. right? It's not using the sorted frequency, it's using the frequency over here. So this is a plot function that's very easy to use. A lot of times it will give you a frequency plot that is already sorted. You just need to mention that how many data output you want over here. And let's remove some store words. I think when you give this chart to any professor, they will not like it because it's like everything else. It's not unique. Let's remove all the store words. Again, this is the one that I debug. They asked me to download it after I remove all the stop words. They asked me to download it specifically before I do the stop words removal. It's kind of library, I believe. So over here, we remove all the stop words. Over here, stop words is what we imported, and also it has a specific library called function, and when you call it English, it will give you a list of stop words. So what we'll do next is every word, you can check every word for word and ask if it is stop words. Like you won't add it to the list if it's a stop word. So this one called words, no stop words, definitely is a word to document that if you are not in a stop words, you are not be in the words, no stop words, right? So this is a function that the tutorial gives that for me, I highly recommend the way that I understand easily and I write often is if this not stop words, you append or you add it to the stop word, no stop words, right? And then we have a frequency no stop words, a frequency plot of no stop words, and you do the same thing again. You find out that yes, there's camera, there's lens, there's Canon, and there's Nikon. You know for sure that the whole text is talking about a coherent stuff for some reason, and then you it's not perfect, of course. You can see use, you don't know what it is. We don't know the context. Great, good. It means I think this text is a comment. So it's talking about how good these cameras are, right? We can learn so much that just the type of camera. We can learn so much, but we definitely have more information in this frequency distribution. And then you make a plot of it. And I think this one you can show to your professor. Definitely, it's really good tokenization because it removed out stop words. It's very good tokenization. It's very informative and representative to the original data set. And you can see that the first word camera has a lot of frequency, but the others not so much. That's what usually happens in a lot of data set. That there's certain words that are frequently mentioned, but others just it's not in the same level. Of course, you can see again that the plot function sorting by itself. You don't need to call the sorted frequency no stop words over here. You don't need to call this one to make a graph, a beautiful plot, stop words distribution plot, right? You just need to do a frequency distribution, and you don't need to sort it, and you just give it a plot function and you mention 30, or you sometimes I don't mention 30, it will show a huge list. This one take a lot, take longer than I thought. It's not returning anything, but right now I go back to 30. See what I get. That's all for the tutorial, but let's show what our result is. It's still loading, but let's show what our result is. After you run it, you get output, and this output is sorted frequency. It's the final result. Of course, you can save the other result, but this result, the sorted frequency, non-stop word, is it's much better. It's very much more informative, right? So let's move over here to see what we get. This is output TST. We successfully made, and today what we just did is, as you can see, we tokenize the words and make it into word frequency, and we remove all the stop words. That's basically what we do. And we turn this huge text that I bet you don't want to read for sure, and into something meaningful. And we know that's what it talk about. And we know that it's talking about a good camera with good lens, maybe come from Canon and Nikon, right? That's it. That's my tutorial for Lab 1. Thank you for watching. Hope you enjoy it. Bye.